I don't know if this is a homework problem or not, but I'm going to do a capacitor problem with you guys just to be sure you know how to do them. And to do that, I have a table here. I would always tell you to make a table, and it's got my original capacitors in it: 6 microfarads, 2 microfarads, 8 microfarads, and 8 microfarads, and there's 9 volts. And our main equation is C equals Q over V. All right. So the first thing we got to do is find the equivalent resistance. And to do that, these two are parallel. And then the 8 is in series with these two, which is in series with this 8. So we're going to start with the 6 and the 2, which when they're in parallel, you just add them. So it's going to be 8. So I'm going to have 8 microfarads there. And then I'm going to draw in my other capacitors. And I'm going to have a 9-volt battery here. And then my 2 resistors here and here that are also 8. And in my opinion, it's very important that you redraw these. All right, so this is 8 microfarads, and this is 8 microfarads, and this is 9.00 volts. Okay, so now these three are in series, and to do that, we do 1 over 8 plus 1 divided by 8 plus 1 divided by 8. Press enter, and you get 0.375, but that's not the answer. That's 1 over the answer, because remember, it's either C equivalent equals C1 plus C2 dot dot dot, or 1 over C equivalent equals 1 over C1 plus 1 over C2 dot dot dot. So we have to say x to the negative 1 to get the answer, and it's 2.67. So our end result is a total capacitance of 2.7 basically microfarads in series with this 9-volt battery. All right. And so the first thing we can do is we realize that in series, the potential difference or the voltage splits up, and the charge is the same. So if I find the charge here, which would be Q equals C times V, then it's going to be Q equals 2.7 microfarads times 9 volts. And that's going to give me 24 microcoulombs. Now, these two blue ones are original, and we know there's 24 microcoulombs here, 24 microcoulombs there, 24 there. So I can go up here in charge and write 24 here and 24 here. I normally would have my units in the CVQ boxes, so I don't have to write it in here every time. Okay, so can I find the voltage at each of these places? Well, the volts are going to be V equals Q over C. Q over C. So what's Q? It's 24, and you divide by 8. So 24 divided by 8 is going to be 3 volts, 3 volts, 3 volts. Well, these two are originals, so 3 volts and 3 volts for that one. And then these two here, let me set this, are in parallel, so the volts is the same. So if there is, in fact, and there is 3 volts here, then it's also 3 volts for both of those. So I'm going to put down 3 volts here, 3 volts here, because in parallel, charge splits up, but potential difference is the same. In series, potential difference or voltage splits up, and charge is the same. That's the reason we could find the charge for this equivalent capacitance and then apply that charge, 24 microcoulombs, to each of these. All right, if I have 2 in this table, I can always find the third one, and Q equals C times V. So it'd be 6 times 3, which is 18. And 2 times 3, which is 6. If you add those together, you get 24, and that's micro coulombs down here. And that's how you do one like that.